Hey everybody, this is Nick Bromick with The Vault. I am just going to explain a little bit about Bifrost in Maya 2018. Really excited about it because it's really made leaps and bounds ever since the initial release in 2015 with Maya 2015. So I'm going to just kind of go over a little bit of simulations, like fluid simulations. I know it's a very robust system and it's really cool and there's a lot of stuff you can do with it, but we're going to just focus on getting people excited about it, kind of an intro level, brand new. You're new to the Bifrost altogether. This is perfect for you because it's we'll go over everything here. It'll be a learning experience and it'll be really neat. So we are going to just be making a milk animation here. So it's just a basic setup that I've had. I have the original scene files, and they will be we'll be linking them in the description here, so you guys can download that, play around with the assets. This start here, so we can get started. So yeah, here this is the basic milk carton. What we're going to be doing is we're going to create liquid, and we're going to put it in there, and we're going to have this thing kind of tip over and pour into this tumbler here. This is a glass tumbler. We will this video will be in two parts. The initial this part one here is going to be about creating the system, refining the details, and getting like a realistic type of a simulation for yourself, and then caching it out. And then part two is going to be very specific to setting it up and creating a lighting scene and rendering it out and making it look very pretty. We're going to be focusing on VRay and how to do it in VRay. However, you can apply the same principles to Arnold or any other renderer that you want. The cool thing is that we're going to be kind of going over physical properties so you can understand a little bit more about what makes it realistic and lighting, so you can take that information and you can apply it over to another renderer, your favorite renderer. But we will also be I'll be putting the files, the project files, online as well. We're going to have this startup here, kind of like a setup, and then the second file will actually have VRay materials and everything you guys can play with. But I recommend that you try to start with the startup here, do everything yourself, and create it yourself, and definitely get in there and tinker around, because that's how you learn. So hopefully we'll get you started enough. Anyway, so I have taken these things and I've created a quick animation so that we can pour the milk in. So the very first thing that we're going to need to do here is we're going to need to create a well, first thing I'm going to get started is I'm going to set my cache location. So let's switch over here to effects. We're going to go Bifrost fluids, and then Bifrost options. I've already done it here. Actually, I have not. I don't know why it's in here. Okay. So what I would recommend is taking this disk location and putting it somewhere where you know you can on a separate hard drive. You don't want to be doing this on your primary hard drive, because these things can get pretty intense, and you can run out of space, and that will kill your computer completely. So I'm putting it here on my Bifrost scratch cache, so that should be good. Okay, and then we'll just apply. That will help everything out quite a bit. And then so the next step is we'll just get into there. The first thing you want to do is you want to select a geo emitter. Now if you switch to wireframe here, you're going to notice this is the only geo that we've got here. In fact, I'm going to modify this geo. We want our walls. This is not a shell. This is actually a solid. So I want to make my walls a little thicker so we don't have any issues there. But the first thing I'm going to do here is I'm going to go to my poly model, and I'm going to create this here. This is going to be our emitter geo, and I'm going to call that milk emitter. Just makes it a lot easier. So I'm going to line it up here, kind of frame it, And there we go. So we'll just make sure that that's the same size, and you don't want it protruding outside of your milk carton geo. So just use a vertex editor and just kind of get in there like that. Switch view. Make sure that's within those walls. Looks good there. I think I've checked all of them. Yeah. Also, how much milk do we want? So let's drop the level down to like there. We'll just be pouring in the rest of the milk. You don't want to overflow it because it will look weird, because we're going to be using a kill plane. We'll get to that. You want to go back into object mode. You can do F8, or if you're on a Mac, function F8. That's going to get you in here. I like to go and freeze my transformations and center my pivot every time I make a change to geo or location. Yeah, we're going to grab this geo and we're going to use that as the emitter. So we're going to go to the effects tab, Bifrost fluids, and then we're going to add or create liquid. That's going to use the geo that we have here to create an emitter. And that's going to give a whole bunch of options here. So I'm going to get right into the meat and potatoes of it, so to speak. And I'm going to get right into attribute editor. And here we go. So first thing I'm going to do is I'm going to make sure that we have some colliders. So I'm going to select this bounding box, and I'm also going to select this as my collider, because without that, you're going to have, it's just going to fall right out of the bottom. So Bifrost, and then we're going to click collider. It's going to add another tab here, collider props 1. We're going to want to change the conversion here to solid robust. That's very specific to this geo here because it's a finer detail. It's not watertight. That's probably the best bet. Second thing you're going to do is it's going to need to collide as well with the tumbler. So we're going to do the same thing here. I'm going to add collider, and you're going to also notice this collider props there. We're going to leave the mode as solid because it's open at the top. It's not as fine of a detail. It's thicker walls. It'll be fine. Okay, so now that we've done that, one thing that you're going to notice when you start playing with this is you're going to get a little bit of overflow sometimes. Some of the particles will drop past where you're trying to get it. What you want to do is you don't want that bounding box to keep increasing, because as those particles go down beyond the floor, it's going to do a lot more calculation. It's going to kill your render times or your simulation times, and it'll just blow up. So what we do is we add a kill plane so that anything that kind of goes too far is those particles are destroyed right at that point, so it's not spawning more and more. So we're going to create a kill plane. Oops, sorry, we have to select the fluid bounding box, and then we'll create a kill plane so it knows which liquid sim to apply. Now, you don't need to make this bigger. I just generally do, because anything on that axis, it doesn't matter. It's kind of like a directional light where it doesn't matter how big it is, it's going to span that entire plane. I just make it bigger so that I can see it, and I remember it's there if I need to raise it or lower it. If you raise it or lower it, you'll notice some things. Now, one thing you want to make sure is that it's not going into your cup, because if that happens, then the particles are going to go into the bottom of the cup, hit the kill plane, and then it's going to keep dying off, and then you're going to notice that you're not retaining any water. So that's a big thing. All right, so let's get into the settings here. What I'm going to do is I'm going to keep this as particles so I can see this. Point size, this doesn't have any effect on simulation time, but as you can see, it's more of a visual thing. It shows you a little bit more. So it's making the point sizes bigger in the viewport. Don't worry about any, I mean, that's different from your resolution. So we're going to definitely make sure that we have scratch cache enabled. That's going to allow us to scrub back and forth, and it's going to kind of cache that on the local drive, the one that we set earlier. What I'm going to do to start with is I'm going to go into the master voxel size under resolution. That is your point size for rendering. So it's kind of similar to this visual one, but that is going to have a hell of a difference on your render times. So I would recommend for at first playing around, change it to 0.3. Keep in mind that the larger your resolution, the more that your actual simulation is going to run differently. So you want to make sure that it's not too high, because if it's too high, it's going to be like marbles in there. It's going to completely be different. If it's too low, you're going to be sitting there waiting for it to simulate forever. Before we do our final render, I'm going to have this and I'm going to put 0.150. Any lower than 0.150, you're going to run into some, it's going to look better, but it's going to take a lot more space. It's going to take a lot more time to render. So we can try out 0.15. If you have a crazy machine at home, you can put that to 0.1. Keep in mind that even with a crazy machine, you're going to be sitting there waiting. Okay, so there is one new cool fun thing about Bifrost and Maya. Now we work in scale, 1 centimeter to 1 meter kind of ratio. So because of that, we have to kind of out of box mess around with some of the settings. I've kind of already done that here. Let's take a look. So I'm gonna open up my outliner. It's really handy to have that open all the time. So I've gone in here to the Bifrost liquid properties container and I've changed the 9.8 gravity to 980 gravity. So you want to do that for sure. Because of the ratio, it's going to behave completely different if you keep it at the default settings. And by different, I mean not in a good way. So the next thing that we need to do if we do that is we need to change the density. And that here is in liquid emitter props. Let's take a look here. Liquid mesh, Bifrost emitter, and emitter props. So there's going to be under emission physical attributes. You're going to see density is going to be by default. It's going to be 1000. We want to change it to 0.001. This is in the Maya documentation as well if you need to take a look at it. They explain about scale and changing this. Okay, so we've got that there. And so the next step is we're going to change some settings in the main liquid properties here. So I'm going to change these settings now. I'm going to explain a little bit about it. So these minimum transport steps and other steps and the minimum time and time steps. If anyone's done simulations before, you'll know that each step kind of has, it's calculating frame by frame and how many times per frame that needs to calculate. And this is usually for fast moving particles so they don't intersect with geo and everything like that, because it's kind of like animation keyframes where it'll go from 1 to 10 and then everything in between will kind of be guessed. Now this will calculate more often to have a more realistic result. Sometimes with your faster moving particles, you're going to need to have something a little more accurate. Now it is definitely way more CPU intensive, so you want to kind of get that fine line. So for this particularly, I was playing with some rather high settings, but it did, because of the movement I needed some of these. So we're getting min transport steps. So I was changing to 10. Let's take a look here. Or sorry, this one. Yeah, so this is 10, and then we'll leave 1000. 0.9 is pretty high. Here we'll do this one as well, 0.9, and then 1 and 7. These are settings that I kind of messed around with back and forth to see what I could get away with. So hopefully that will not be too high. I mean, I'm not running the craziest machine. It's a 2010 Mac Pro Tower with some heavy video cards, but the video cards, everything's being done on the CPU anyway. So chances are, if you've got a decent machine, it will handle this particular project. So once we've done that, we want to go in and add some friction because when this moves and this opens or when this pours out, it's going to kind of shoot out pretty quickly. We want to add some friction between the liquid and the geo. Now we're going to have to do this for both of them. So I'm going to grab this guy, and grab this guy. And then we're going to do Bifrost fluids, and then we're going to create a motion field. Now in the motion field, we will have that come up here. There's a few things that I want to do here. Direction we're going to turn off because we don't want any extra direction going on. And then drag we're going to turn on, and geometry and we're going to want to keep on as well. Scale, effect, speed, we'll keep that as well. Now we'll open up the drag, and for the drag I've changed it to 1.0 because I really want it to slow down a bit, and then the normal drag also 1. What I'd recommend is looking up on in the documentation what every one of these parameters does, playing around with the settings yourself and kind of experimenting. If you've got some time, it's really good to do because you get to know it and you get to know what works and what doesn't, rather than just listening to me tell you which to change. And then here what I'm going to do is I'm going to go to velocity and speed clamp. I'm going to make sure I clamp speed. Again, that's slowing things down. And then the geometry part, we're going to enable the fall off. I'm going to change the minimum distance to 0. Maximum distance is going to be 0.066. Along normal 0. Friction I am going to set to 1. And inherit velocity, we're going to keep that as well at 0. So that right there should probably get you pretty set up. What you can do is get in there, and we'll go to the first frame. I'm actually going to set this frame to 100. As you can see, the keyframes here will stop at 44, but at least we'll have some residual stuff going on with the milk after it's finished being poured. So I'm going to run a simulation here real quick, and we'll see what we come up with. Once the simulation is completed, you'll notice that your timeline has gone green. That's indicating that all those frames have been cached to the scratch disk or scratch cache. If you don't see that, if you don't see the green, you'll just have to select that liquid container and then you'll be able to see it from there. What I'd recommend doing is doing a play blast because, as you can see, we've got a play blast here showing you exactly what's going on. That's going to give you a good indication as to whether there's any kind of intersection, any weird popping, anything going on. It's going to show you real time what the simulation looks like, if it looks weird, if whatever's going on with it. That's going to be able to allow you to troubleshoot. Because once you have something looking pretty decent, the next step is to cache the disk. So, because right now this is using your RAM to do it. So, what I'm going to do before I do my final cache to disk, I'm going to go in here and I'm just going to go into the attribute editor, and I'm going to, let's take a look here, go here, attribute editor, and I'm going to make sure, I'm going to change a few things. Like I said, if you do have issues with your, with the, like particles escaping, stuff like that, the things that you want to check are transport and the time stepping, min transport steps. This right here, you can crank that way up. If you're having major issues, crank it up to like 50. That will do more steps. Calculation time will take more time for sure, but it may be able to get rid of some of those issues. Another thing you want to check is your geometry. Is your geometry too thin? So emitter props 1. You're gonna want to make sure that this, like for this particular one, check your mode. Your mode for conversion should be solid robust. So this one here, actually, this one's solid and it's working out really well. If you have finer detail, switch the solid to solid robust. That's going to give you a little bit more leeway with things that aren't watertight, things that have like finer detail. If those walls were thinner, you'd want to switch to this. Otherwise, you get things actually leaking out. I'm going to switch it to solid robust too, just because I'm going to make a change here that may have a major impact on that. And that's going to be the resolution. So I'm going to go in here to the resolution. That would be under Bifrost liquid, and it'll be under the liquid shape. Properties container, and then your master voxel size. Now, before I do the final cache, I'm going to switch that from 0.3 to 0.150. 0.150 will give you some pretty fluid stuff. It won't be as chunky. 0.1, you're getting pretty intensive. It's going to be eating into your scratch disk as well. So make sure you've got a lot of space on your drive. But yeah, let's go ahead with this. I'm going to make that change there, and we're going to set up the setting here for the Bifrost options. You want to make sure that enable background processing is off and enable scratch caching is off, and then you want to override that disk location. That looks all good. And then the second thing you want to do is you want to do compute and cache to disk. Click on this little box here and make sure you are in there. So we've got it here, milk pour setup. That looks good for me. Cache BIF simulation. I'm going to keep it selected on simulation. We can generate a mesh as soon as we're done, so I'm going to keep that on there. Time slider, we're going to keep what's set there, 1 to 100. No, you can type it in manually here if you want, but I would recommend just going time slider. Make sure yours set to 1 to 100, not 0 to 100, because you could run into some issues apparently. So once you have all that set up, I'm going to hit apply, and that's going to get the actual, it's going to do another simulation, and simulating to disk. So that concludes that video. So video 2 is going to go a little bit more into depth with creating a geometry based on this. So we're going to convert this simulation to mesh, and then we're going to make it really pretty by adding some materials, some VRay shaders, and then we're going to get some basic lighting in there, and we're going to render it out so it's a photorealistic video. We will be releasing that video next week, and we can continue from here. Thank you.